All right, are you ready to jump into Java coding? We're going deep with this piece on basic Java techniques, and let me tell you, it's gonna be a fun one.
Oh yeah, this stuff is really cool once you get into it.
Especially if you've ever thought, how does code actually work? This is the deep dive for you.
We're talking about the logic behind it, the structure, like how to actually speak the language of Java.
Okay, so the source kicks off with a simple example, just adding two numbers.
Right, got to start somewhere.
But I like that it's got this side-by-side thing showing the plain English instructions and then the actual Java code.
Yeah, that's super helpful for understanding what's going on.
But I'm seeing IN1 and IN2. What's that all about?
Ah, those are variables. Think of them like containers, but they're in the computer's memory.
Okay.
And they each hold a specific piece of information. Like IN1 might be holding the number, say, 23, and IN2 has 43.
So are we just giving these numbers nicknames to keep track of them?
Pretty much. The names are more for us, for our human brains.
Ah.
The computer doesn't care what we call them. It just needs the values they represent.
So it's like I can remember my friend by their name, but the computer's using their phone number.
Exactly. Both identify the same person, just in different ways. And that's a big thing to wrap your head around with coding, separating the idea of data from how Java forces you to represent it.
Wait, so there's like a whole system for how the computer remembers all this?
Oh yeah, that's memory management, a huge part of programming.
It's more than just adding two numbers now.
When you make a variable, you're setting aside a little spot in the computer's memory for that value.
Mind blown. Never thought of it like that. It's like peeking behind the curtain as how computers think.
That's the fun part, right? We're not just memorizing code, we're figuring out what's really going on underneath.
Okay, this is starting to click now. But what about making our code, a little smarter? I'm seeing something here about if-else statements. Is that like giving the code choices?
You got it. Imagine you're writing a program, and it needs to do different things depending on certain conditions. That's when if-else comes in.
Oh, I see.
It's like giving the code a set of instructions, but with options.
Can we use the example from the source? I think it was checking if a number is greater than 5.
Sure, yeah. Let's say IN1, our variable from before, still has the number 23 in it. The if statement checks, is 23 greater than 5?
And if it is?
If the answer is yes, then the code runs a certain block of instructions. If not, it jumps over to the else part and does something else.
So the code isn't just blindly following orders, it's like making decisions.
Exactly. And that's the whole basis of algorithms. Those step-by-step guides that tell a computer how to solve a problem.
Wow, it's like giving the computer a little brain. But hold on, what if we wanted to do something over and over again? Like count to 100. I'm not going to write 100 lines of code, right?
Huh. You're thinking like a programmer already. That's where the magic of loops comes in. They let us repeat a chunk of code without typing it out a million times.
Loops, huh? Okay, give me the rundown. What are they all about? Okay, loops. Are we talking like the kind that make you dizzy on a roller coaster?
Haha, not quite. But they are kind of like hitting the repeat button on your favorite song.
For instructions, not music.
Exactly, for instructions. It's how you make a piece of code run multiple times.
Okay, that makes sense. But why are there different kinds of loops? Can't they all just do the same thing?
Well, different loops for different jobs, you know? Like you wouldn't use a hammer to build a whole house.
Yeah, that's true. What's the first one the source talks about?
For loops. Those are your go-to when you know exactly how many times you need something to happen.
So if I want to count from 1 to 10.
Perfect example.
Oh.
Or, say you're working with a list that has 5 items in it, a for loop is your friend.
All right, so predictable number of times, go with the for loop.
Yep. And it's got this super clear structure, too.
Okay, lay it on me.
You set a starting point, like where you want the loop to begin, then the condition for when it should stop and how much to increment by each time.
Back up a sec. What's increment?
Oh, good catch. Basically, it just means adding 1 each time the loop runs.
So if I'm starting at 1 and going to 10, I increment by 1 until I hit 10.
You got it. Like taking steps up a staircase one at a time. But what about those situations where you don't know how many times you need the loop to run?
Ooh, good point. Like if the computer's playing a game and it needs to keep going until it wins, but we don't know how many tries that'll take.
Exactly. That's when you'd use a while loop. They're like the adventurous sibling of for loops. They keep running as long as a certain condition is true.
So it's like saying, keep doing this thing until this other thing happens.
Yeah, exactly.
This is all kind of abstract, though. What would this look like in actual Java code?
Ah, good question. Let's go back to that adding numbers example. Remember our variables IN1 and IN2.
Yeah, the containers for our numbers.
Right. Instead of just plugging in the numbers directly, What if we wanted the user to type in the numbers they wanted to add?
Ooh, make it interactive.
There's this handy function in Java called scanner that can read what the user types in.
So the user types in their numbers, and then the computer puts those values into IN1 and IN2.
Yep, and then it adds them together. Same logic as before, but way more dynamic, because now the user can choose different numbers each time.
That's pretty cool. So that the logic stays the same, but it's more flexible.
That's the power of variables.
Yeah.
They make our code way more adaptable. And this is just the beginning. Remember those if-else statements we talked about?
Uh-huh.
We could even add one of those in, just to spice things up.
So, like, the code could check if the numbers are positive, and else it asks the user to try again.
Exactly. See, now we're combining these building blocks, and things are getting interesting.
This is awesome. We've got loops, we've got user input. I can see how this all builds towards making something really complex.
Yeah, it all starts with these basics.
There's one more type of loop the source mentions, though. The enhanced for loop. What's so enhanced about it? All right, enhanced for loop. Lay it on me. Is this like loops on steroids?
Kind of. It's specifically for working with collections of data, like, lists or arrays.
Okay. So it's built to handle lots of information at once.
Exactly. Makes it super easy to go through every item in that collection.
When would you actually use this?
Remember we talked about processing 1 million customer orders?
Yeah, that was a lot of orders.
Imagine each order is like one entry in a giant list. The enhanced for loop would let you neatly process each order, one by one.
Like to calculate the total sales or something?
Exactly. Or figure out which products are selling like hotcakes. It's way more efficient than doing it manually.
I can imagine. But wait, didn't we already have for and while loops? Why do we need this other one?
It's all about writing cleaner code, especially with collections. With an enhanced for loop, you don't have to mess around with counters and incrementing like you do in a regular for loop. It just takes care of all that for you.
So it's like, hey, I got this. You worry about what you want to do with each item. I'll handle the rest.
Pretty much. You can focus on the logic of what you're doing without getting bogged down in the details of accessing each element.
Okay, I'm seeing why it's enhanced. It's like taking the shortcut through the maze. But now I'm wondering, with all these different loops, how do I know which one to use when I'm actually coding?
Ah, the big question. It really depends on what you're trying to accomplish. No one-size-fits-all answer.
So help me out here. What are the guidelines?
Okay, think of it this way. If you know exactly how many times you need the loop to run, like counting from 1 to 10 or going through a list with a fixed number of items, the for loop is usually your best bet.
All right, fixed repetitions, for loop. Got it.
But if the number of repetitions depends on some condition, like say a game that keeps going until someone wins, then a while loop is what you need.
While loop for those times when you don't know how long it's going to take, right?
Exactly. And if you're dealing with arrays or lists, lots of data like that, the enhanced for loop is there to make your life easier.
Enhanced for loop, the data superhero. This is starting to feel like a whole toolbox for different coding situations.
That's the idea. The more you practice, the more you'll just know which loop to grab. It's like learning a language. At first you have to think about every word, but eventually it just flows.
You know, I gotta say, when we started this deep dive, I thought Java was gonna be this super intimidating beast.
It can seem that way at first.
But you've broken it down in a way that actually makes sense.
Glad to hear it. And remember, this is just scratching the surface. Java is a huge and powerful language. There's so much more to explore.
Whoa, that's kind of exciting and kind of scary at the same time. So for anyone listening who's thinking, okay, I get the basics, but where do I go from here?
Keep exploring. There are tons of resources out there, online tutorials, communities where you can connect with other coders. Don't be afraid to experiment. Try things out.
The key is to just keep learning, right?
Exactly.
Yeah.
Never stop being curious.
All right, listeners, that wraps up our deep dive into Java coding basics. We tackled variables, if-else statements, and even the wonderful world of loops.
Hopefully you're feeling a lot more confident about how code works and what you can achieve with it.
Who knows, maybe this is just the beginning of your coding journey.
Keep practicing, keep learning, and most importantly, have fun.
Until next time, happy coding.